Good morning students. Today we will discuss about photoelectric effect. So what is meant by photoelectric effect? So see here, when light falls on the metal surface, what happens? Electrons get ejected. So which light falls on the metal surface? So this light may be any electromagnetic radiation. Any electromagnetic radiation means, for example, it may be visible light, it may be ultraviolet radiations, it may be infrared radiations, etc. So any electromagnetic radiation, when it falls on metal surface, electrons get ejected. So how much energy electromagnetic radiation should be focused, should strike the metal surface? That is, the energy should be more than electron or it should be equal to electron. For example, when somebody are sitting, when I want to lift them, how much energy I need to put? Equal to their energy or otherwise greater than their energy. So when electromagnetic radiation of sufficient energy falls on metal surface, then only electrons get ejected. This phenomenon we call it as photoelectric effect. So see here, now if we want to define photoelectric effect, so definition is the phenomenon of emission of electrons from certain metal surfaces when electromagnetic radiations such as ultraviolet rays, X-rays, visible light of sufficient energy, when they fall on metal surfaces, what happens? The electrons get ejected. This is called as photoelectric effect. And the electrons ejected are called as photoelectrons. Now, this photoelectric effect was first discovered by Hertz. Scientist name Hertz in 1887. Next, see here which electromagnetic radiation he has used. He has used first, the experiment is done with ultraviolet radiations. So, photoelectric effect was first discovered by Hertz and this experiment is done with the help of ultraviolet radiations. Now, we will see the experimental arrangement of photoelectric effect. So, this is the schematic representation of photoelectric effect. Now, this is the evacuated quartz bulb. So, this is the evacuated quartz bulb. So, this evacuated quartz bulb consists of cathode and anode. This cathode and anode are prepared with zinc plates. So, evacuated quartz bulb consists of two zinc plates which acts as cathode and anode. Here cathode is connected to negative terminal of the battery and anode is connected to positive terminal of the battery. So see here, when photons means when light, electromagnetic radiation, when it falls on metal surface. So when it falls on the metal surface, this is the metal surface, cathode. So when it falls on cathode, what happens? Electrons get ejected. These are the electrons getting ejected. They move from cathode to anode. They move opposite to the electric field. They move from cathode to anode. How to know that the emitted ones are electrons? So see here, this can be known by ammeter. See here if ammeter shows the deflection, then the flow is due to electrons. Okay, so this is the experimental setup for photoelectric effect. So see here, it consists of two zinc plates which acts as anode and cathode, which is placed in evacuated quartz bulb. Next, here cathode and anode are connected to, cathode is connected to negative terminal and anode is connected to positive terminal of the battery. Now, when light falls on, when ultraviolet rays falls on cathode, there is flow of current, means the electrons are emitted. They are moving from cathode to anode. So this is about the experimental setup. Next, observations drawn from photoelectric effect. So what are the observations drawn from photoelectric effect? First one is, see here, electronic emission increases with increase in intensity of radiation falling on metal surface. Means, see here, if intensity means if brightness of the light increases, means if number of photons increases, what happens? If number of photons falls on metal surface, what happens? The number of electrons also, the number of electrons emitted also increases. So electronic emission increases as the intensity of radiation increases. Next, see here how much energy is required to emit an electron. So it should be, we have written that sufficient energy. Sufficient energy means energy of photon is h nu. So from this, some amount of energy is sufficient to excite to remove an electron from the metal surface. So the energy sufficient is h nu naught. So h is constant. Now nu naught is frequency. So h is constant. Energy depends on nu naught. This is the frequency. See here, the minimum frequency of light more than nu naught. More than this, then only photoelectrons are ejected. This is called as threshold frequency. This is called as threshold frequency represented by nu naught. So if the frequency is more than threshold frequency, then only photoelectrons get ejected. Next, the photocurrent varies. See here photocurrent varies with respect to frequency of incident light. Means it depends on frequency of light and it depends on applied voltage. But it is independent of intensity of light. Okay. So here photocurrent depends on frequency of light and depends on applied voltage but independent of intensity of light. So see here, be careful here, electronic emission depends on intensity of light. But here photocurrent independent of intensity of light. It depends on frequency of incident light and applied voltage. So these are the observations. So what are the observations? Electrons emitted will be more when the intensity is more. Next, the minimum frequency required to eject an electron is threshold frequency. Next, photocurrent depends on frequency of light and applied voltage and it doesn't depends on intensity of light. These are the observations. Next, if we go for characteristics, the characteristics of photoelectric effect are, so there are two characteristics of photoelectric effect. One is variation of photocurrent with frequency. Means here photocurrent depends on frequency. So this is one characteristic. Next, photocurrent depends on applied voltage. Next characteristic. So the characteristics of photoelectric effect are variation of photoelectric current with frequency and next one is variation of photoelectric current with voltage. Now first if I see first characteristic, the variation of photoelectric current with frequency. Now we'll see the variation of photocurrent with frequency for various intensities. Okay. Now, so this is the graph for variation of photocurrent, variation of photocurrent. This is the photocurrent. Means the emitted electrons are called as photoelectrons. Due to photoelectrons, there will be photocurrent. Photocurrent IP. Photocurrent is represented by IP. Next, here this is frequency. So this is the frequency of incident light. This is the graph between photocurrent and frequency of incident light. So what happens? Initially up to threshold frequency nu naught, up to threshold frequency nu naught, There is no current, because in order to get electrons emitted, you should give sufficient energy, sufficient frequency. Sufficient frequency is represented by mu naught, threshold frequency. Okay, up to threshold frequency there is no current, but after threshold frequency what happens? As the frequency increases, photocurrent also increases. As the frequency increases, photocurrent also increases. So this can be shown for different intensities, different intensities. Okay, now, so this is the graph between photocurrent and frequency of incident light. So what happens? Initially there is no current up to threshold frequency. After threshold frequency, as frequency increases, photocurrent also increases. Okay, next, so see here once what we have discussed till now. Photocurrent is increased by increasing frequency. Okay, next if we move for next characteristic, so next one is the variation of photoelectric current with applied voltage. Okay, now we will see the variation of photocurrent with applied voltage. So this is the photo current and this is the applied voltage. Now, if we see the variation of photocurrent with applied voltage, now see here from this graph, at this point, at this voltage V0, this is for voltage, this is for voltage. At applied voltage, at certain applied voltage V0, the current is 0. Here current is 0 at certain negative potential, means at negative voltage the current is 0. So this I call it as stopping potential. So stopping potential means it is the potential at which current becomes 0. After this when it is moving towards positive x-axis, what happens is, as voltage increases, current also increases and it attains saturated value. So it is shown for different intensities, I1 and I2. Here I2 is greater than I1. Okay, now, so see here photocurrent is measured by varying potential between anode and cathode, keeping intensity of light and frequency of light constant. So I am varying only photocurrent and voltage applied. I am keeping frequency of light as constant. Now, so see here, when the potential is below minimum value, so at minus V0, photocurrent is becoming 0. That we call it as stopping potential. Next, when potential is increased towards positive, after stopping potential, what happens? Photoelectric current also increases and it attains saturated value. So these are the characteristics of photoelectric effect. So this is about photoelectric effect. Thank you.